everyone, this is Shiba Tutoring and I will be doing a series of videos that cover the entire Maths Higher GCSE syllabus, mainly for AQA and Edexcel. This is part 1 of 6, Numbers and Operations. Just before we get started, I just want to make it very clear that any question with a star next to the number, you are allowed to use calculator. If you would like to attempt the question, please pause the video and then unpause when you're ready. Question 1. We have two fractions to add here. It's 1 and 2/3. Add 4/5. Okay, so what I would recommend here is for the mixed fraction to turn that into an improper, whether you're adding, timesing, dividing, subtracting, any improper fraction you want. Okay, in place of a mixed number. So 1 times 3 is 3, add the 2 is 5 over 3, add 4/5. Okay, so what I could do here is I can times this side by 5 and this side by 3 because we want a common denominator. Okay, that's 5 times 5 which is 25, 5 times 3 which is 15, 3 times 4 is 12 over the 15, so this becomes 37 over 15. And we could leave it like that. It's not asking us to put it into a certain place, but you could also put it back into a mixed fraction. So 15 to the 37 is 2. There's 7 remaining over 15. And we're done. Number 2a and b, we have decimals, we have multiplication and dividing. So let's start off with a. 0.57 times by 8.5. Okay, what I'd recommend here is to ignore the decimal point, so we have 57 and 85. Let's multiply them together. 7 5s are 35, 5 5s are 25, add the 3 is 28. Now we're moving on to the 8, which is a tens column, so add a 0, 7 to 8 is 56, 5 8 are 40, add the 5 is 45. Now just add these together, just make sure these are lined up correctly before adding. So that's 5, that's 14, 5 at 2 is 7, at the 1 is 8, and 4. So our digits are 4, 8, 4, 5. Now, to put a decimal place back in, how many places are there after the decimal point? There's 3, so we're going to jump back 3 places. Okay, so there we are. That would be 4.845. Part B, we have a division. Now this doesn't work the exact same ways as multiplication. What you want to do, the divisor, which is 0.4, you want to turn that into a whole number, in this case 4. I could do that by timesing by 10 to move the decimal point. But whatever I do to one side, I must do to the other side. So this becomes 76.8 divided by 4. And now we can use the bust up method, the divisor on the outside, 76.8 on the inside. 4 to the 7 is 1 with the remainder 3. 4 to the 36 is 9. Decimal, 4 to the 8 is 2. And that's it. Question 3, 3a, we have standard form. 8.23 times 10 to the power of 5, and it wants it into an ordinary number. Okay, now if I jump 2 places to get past the 3, that's 2 places already jumped. So think of this as the number of places to jump. So it will be 8, 2, 3. Now there's 2 places jumps, so 3 left. Just fill those extra jumps with zeros. And there is our normal number. So just double check. 1, 2, 3, 4, 5. That's done. Part B, we have 2 sets of standard form and we're going to divide. So just going to write this out first. Now when you're dividing, or multiplication, what we are aiming to do is we're going to divide the 3.5 by the 7 and the 10.5 by the 10 to the power of 5 divided by the 10 to the power of 8. Okay, let's start off with 3.5 divided by 7. Okay, well, this will just be 0.5. 10 to the power of 5 divided by 10 to the power of 8. Using the indices rule, if we have division, the same base, we take away the powers, so this will be 10 to the power of negative 3. So what we have is 0.5 times 10 to the power of negative 3. However, if we left this answer as it is, we would lose a mark because this is not standard form. Remember, standard form must be a times 10 to the power of n, but the a must be between 1 and 10. So we do need to sort this out. What I can do is I could write this as a normal number just to see what's going on. Okay, 1, 2, 3. Yep, that's what it is. That's what it is as a normal number. Now, what is that as standard form? 1, 2, 3, 4. So I need it to there. So this would be 5.0 or just 5 times 10 to the power of -4. And that is our final answer. Question number 4. Write 490 as a product of its prime factors. Okay, so 490 as a product of its prime factors. So what we want to do is do a factor tree. And a prime factor is just a prime number, so a number that can only be divided by itself in 1. But it's also a factor, so it's a number which will go into 490. That also happens to be a prime number. And we do this by using factor trees. So two numbers that multiply together to get 490. I could use 49 and 10. 10, I could break down to 5 and 2. Notice that these are both prime. 49, 7 and 7, both prime. So this means this will become 2 times 5 times 7 squared. That's A done. Part B. Buses to Ayton leave the station every 25 minutes. Buses to Bleaford leave the station every 40 minutes. Buses to both places leave at 9 AM. What is the next time buses to Ayton and Bleaford leave the station together? Okay. So what we have here is either it's going to be HCF or LCM. Okay. Now, which one is it going to be? Well, if we're repeating minutes, so like 25, 50, etc., we are looking at LCM. If we're looking to share within a certain amount, it will be HCF. But because we're repeating these minutes, as in multiples, it's LCM. So let's start off with the 25 minutes. So 25, 50, 75, 100. Just keep going for just a small amount of time. Okay, I'm just going to leave the 25 there. Let's go into the 40, 40, 80, 120, 150. Oops, not 150. 40, 80, 120, 160, 200. Notice how actually I have the lowest common multiple already is 200. So as soon as we get to the first number that's in common, this will be our lowest common multiple. So what it's saying is that after 200 minutes, that's when the two buses will arrive at the same time again. Well, what is 200 minutes? Well, this is 180 minutes, which is 3 hours, plus 20 minutes. So we're looking for 2 hours and 20 minutes from 9 AM. This will be 3 hours, of course, will be 12 PM. Oops, 12 PM and 20 minutes. That'll be 12.20. So 12.20 PM. And that is our final answer. Question number 5. We have a highest common factor and LCM question, but based on two sets of numbers. A and B are both large numbers, as we can see. No need to turn it into numbers. We could just leave it as A and B. A good way to do this for highest common factor, if you're looking for the highest common factor or LCM for two or more numbers, is to draw a Venn diagram. So A and B. Now, what do they have in common? They have a 7 in common. So I'm just going to put a 7 there. Now, this is 7 to the power of 3 and this is 7 to the power of 4. So the common amount is 7 to the power of 3. B does have an extra 7. Okay, they also have 3's in common. They got 1 3 in common. It's just A has an extra 4. B exclusively has 2 to the power of 3. And A exclusively has 5. So there is our Venn diagram. Just to double check, just focusing on A, we have 3 to the power of 5, yep. 5, yeah, and 7 to the power of 3. And then focusing on B, we have 7 to the power of 4, yeah, 1, 3, and 3 loads of 2s. Okay, that's definitely correct. So if we're looking for the HCF, to do this, you just focus on the intersection, and that's 3 times 7 cubed. So the intersection will give you the HCF. So 3 times 7 cubed. This is the HCF. B, the LCM. Now when we focus on the LCM, you just multiply everything inside of the Venn diagram, and that'll be the union. And we could write it as numbers in a base form with the powers. So this would be 3 to the power of 5 multiplied by 2 to the power of 3 multiplied by 5 multiplied by 7 to the power of 4. Okay, and that's it for A and B. Okay, part C. Okay, so we have 3 sets of numbers this time. And we are given some information about the HCF and LCM, and we're looking for what PQR is for C. This is a bit of a tricky question, to be honest, but you just want to take your time. If this was an exam and you weren't sure, just give it your best shot. You never know, you might get some marks from it. So I'm going to do 3 Venn diagrams. Okay, A, B, and C. Okay, so remember the intersection for all of them. So what do they all have in common? They all have a 7 in common. So I'm going to put a 7 there. I'm just going to set all of these up as well, actually. 2 to the power of P. So P equals, and then the same 5. Then it's 7 to the power of R. Okay. So they have a 7 in common. So let's look at this HCF of B and C. It's 2 to the power of 3 times 7. Now the HCF of B and C is this part. Okay. I know that includes an A, but if we are including, if we talk about the HCF of B and C, that will be that part. Now what it's saying is there's a 7 in there. Okay. Now that's immediately telling me that the B, with the B and A, there's another 7, remember? So if that's true, we can possibly put a 7 there, but I'm just going to leave that alone for a while, but I think that's what's going to happen. But the HCF of B and C is 2 to the power of 3 and 7, so I'm going to put 2 to the power of 3. Remember, A does not have a 2, so I can put a 2 to the power of 3 there. Okay, that's sorted. Now let's look at the LCM of A and C. So the LCM will be all of this. And what it's saying is that the LCM is 7 to the power of 3. Okay, remember C only have if the HCF of B and C is 7, and it's talking here, the LCM of A and C is 2 to the power of 4, 3 to the power of 5, 5 to the power of 2, 7 to the power of 3. That means there will be another 7 in that part. Okay, but B also does have a 7 as well, actually. Okay, so what I'm led to believe here is that the only 7 that C can have is the intersection point. So I am going to put a 7 there. Okay, so if the 7 goes there, B does have a 7 to the power of 4, but the LCM of A and C is 3, 7 to the power of 3, so that means this extra 7 must go there. Let's just double check that with the 7s. So B has 4 7s, okay, so if that's the case, this is wrong, this should be a 2. Okay, so now this makes sense, because B has 4 7s, A has 3 7s, and C looks like it's going to have 1 7 because of the HCF of B and C. Okay, now 7s, that means I've sorted a 7, so that'll be 1, so R is 1. Okay, let's look at the LCM of A and C again of the 2s. So B and C both do have a 2. There already is a 2 to the power of 3 there. And if the LCM of A and C is 2, then that means where's the extra 2 going to go? So A does not have 2s, so the 2 must go there. Okay, that makes it that the C has 2 to the power of 4. Okay, again, reminder, LCM of A and C has 2 to the power of 4. So that is done. So P is equal to 4. And lastly, the 5. Okay. A and C, again, LCM of A and C is 5 to the power of 2. Right. B does not have a 5, of course. So where is this 5 going? Okay. So that A has 1 5. So if I put a 5 there, and the LCM of A and C is 5 as well, remember C does have a 5 as well. Okay, let's just see if this works. So A has 1 5. Yeah, that's true. And C has 5 to the power of Q, but in the LCM of A and C, we do have 2 loads of 5s. So this does check out. So Q is equal to 2. And that is done. Number 6, Redox hand wash is on offer at Boots and Superdrug. Boots 500ml on offer at 3 for 2. Superdrug 300ml, buy one get one free. Assume that both prices are the same. Where is the hand wash better value, at Boots or Superdrug? You must show you're working. That's very important, because if you just choose Boots or Superdrug without working, you will get no marks at all. So this is a best value type question, where we're comparing values for more than one shop. So for example, Boots, 500 millilitres on offer at 3 for 2. So you need to think of, what are we paying for here? We're paying for 2, and what we're getting is 3, so we're getting 1500 millilitres. Okay, 300 millilitres bottles on offer at buy one get one free for Superdrug. Now if it's buy one get one free, I can get in a situation where I'm buying for 2 again. So two bottles. Now if I do buy one get one free, that means I'm going to get 4. But I am paying for 2, so looking from the point of view of what you're paying for. Okay, so 4 times 3, remember it's buy one get one free, which will be 1200 millilitres. Okay, so we're paying for 2 bottles each time. So paying for 2, and then what we have is Boots, it's 1500 millilitres. Okay, 4 that are paid amount, and Superdrug, 1200 millilitres for the paid amount, which is 2. So in that case, Boots is better value. And that's done. Question number 7. Write 2.742 as a fraction in its simplest form. You must show you're working. So this is a recurring decimals question. 2.742. Now what this is saying is the 4 and the 2 are the numbers that are recurring. Oops. 42, 42, 42, etc. right until the end. Okay, what you want to do is you want to first get a decimal point past the non-repeating number, which is 7. I'm going to call this x. Now if I get it past the 7, I would have to times this by 10. But of course the 4 and 2 is still repeating. Next you want to get it past the repeating digits, so I would have to times the original x by 1000. This would be 2742, but the 4 and 2 is still recurring. Okay, now what you want to do next is you want to take away the 10x from the 1000x, because if you notice, this will get rid of the 4 2's that are repeating, which is good, because then we'll be able to divide afterwards. So this would be 2742, take away 27, which is 2715, and this is 990x equals 2715. And then what we could do here is divide through by 990 to rearrange for x, and this will be our fraction, but we want it in its simplest form, so I'm just going to divide. And that is 181 over 66. Okay, just leave it like that, and that's done. Question 8. We have a recurring decimals question again, but this time we've been asked to divide. Okay, just sort out each one separately. Okay, so I'm going to let that be x. just like before, we would need to pass the repeating, so I'm going to times this by 100, and this would be 39.39 recurring. And now I can just take them away from each other, and that would knock out the repeating numbers. That would just be 39, and this becomes 99x equals 39. Divide through by 99. This becomes 1/3 over 3/3. Just leave that to a side. Let's call this the 0.63 recurring. I'll call this y. And exact same method. Y equals, take it away first, so that's going to be 99y equals 63, divided by the 99, and this becomes 21 over 33. Yep, and now it's ready to divide. So we have 13 over 33 divided by 21 over 33. Now division fraction, so we're going to keep, change and flip. And because it is a division fraction, we can cancel down diagonally. So this will be 3 and 3. Okay, and it looks like that's everything I can do. So I'm just going to just times this now. Oh, I can go a bit further actually. I can just say this is 1 and 1. Okay, now it's ready. So 13 times 1 is 13. 1 times 21 is just 21. So there is our final answer. Question 9, we have a bounds question here. And these sorts of questions can trip people up quite a bit. So I would always recommend, when you get a question like this, especially if it's 4 marks, just plan what we need to do. Okay, so what it's saying is we have x, a, and m, and we could see what it wants it correct to the nearest point in terms of, this is immediately must think bounds, especially when it says lower bound, of course. All right, so what we're looking for is how do I get the lowest point of p? Well, in terms of a fraction, we have a fraction here. Let's say we have a of b, and I wanted to work out the lowest possible version of this fraction. Let's just use some numbers here, for example. If I change a to an 8 and b to a 2, of course that would give us 4. But what happens if I increase the denominator to a 4? Notice now the answer has gotten smaller, which is telling me that if I increase the denominator, so let's do this again. If I increase the denominator, I can get a smaller version of p. What about a, the top? If I change 8 to, let's say, 6, notice again, we got a smaller version than 4. So that means if I decrease the numerator, I can get a small version of p. Okay. However, b, the upper bound of b, it is n minus x. Now, how do I get the biggest possible value of n minus x? Well, if I increase m, or get the biggest value of n possible, take away the smallest amount of x possible, this will give me my biggest value of b. Right, so there we go. Let's just put this all in place. So m upper bound, take away x lower bound. Right, now it's ready to fill, but I need to just sort these out first. So 8 corrects 1 sig fig. Well, 1 sig fig here is just 1 unit. Okay. 4.6 corrects 2 sig fig. Now, the second sig fig is the 1 decimal place. So it's the nearest 1 decimal place, which would be 0.1. 20 corrects the nearest 10. Well, the nearest 10 is just a tens column, of course. So it's just 10 here. Right. Now, when we're doing bounds, it's going to be plus or minus the half of each of these. So 1 unit will be 0 plus minus 0.5. 0.1 is plus minus 0.05. And a 10 plus minus 5. Okay, so just to show you what I mean, if we have 8, and I'm looking for the lower bound and upper bound, Let's say this is the upper bound, this is lower bound. Oops, not yet. This is 9 and this is 7. Okay, so these are going to be the upper bounds. This is the upper bound and this is the lower bound. Okay, if you notice, if I just go halfway, that's going to be 8.5 and this is 7.5. Okay, these will be our bounds, 7.5 and 8.5. Okay, but what do I actually want here? I want the A lower bound. Okay, if I want the A lower bound, well, I haven't done A yet, but for the X lower bound, I definitely want the 7.5. Okay, now just do X quickly, so that's done. For A is 4.6. Okay, let's do A. Now what do we want for A? We want the lower bound of A. A is 4.6, correct to 2 sig fig. I want the lower bound, so I'm going to take away 0.05. So 4.6 take away 0.05. Okay, this will be 4.55. And we want the upper bound. And now to get the upper bound, I want to plus 520, which would be 25. Okay, so just put the X here as well. The X lower bound is 7.5. Okay, so ready to fill in. So the P lower bound is the A lower bound, which is 4.55, divided by the M upper bound, which is 25, and take away the X lower bound, which is 7.5. And then if you put that into your calculator, just double check everything, it's okay actually. Yeah, it looks good to me. And then just fill that all in into your calculator and you'll get 0.26. And that's done. Number 10a, show that 6 plus 2 root 12 squared is equal to 12 brackets 7 plus 4 root 3. Show each stage of your working. Okay, so what I'm going to do is just start by writing out the 2 brackets and we're going to expand these 2 brackets. Okay, I'm going to use the FOIL method. 6 times 6 is 36. 6 times 2 root 12. That's just going to be the 6 times 2, which is 12. Root 12 gets left alone. Same thing here. 2 root 12 times 6, that's plus 12 root 12. And then lastly, 2 root 12 times 2 root 12. If you're not sure, just write it on the side. 2 times 2 is 4. Root 12 times root 12 is root 144. So that's 4 times 12, which is 48. Okay, simplify this a bit further. 36 and 48 is 84. So that becomes 84 plus 24 root 12. Remember, when you're simplifying surds, as long as the surds are the same, we can think of them as like terms. Okay. Notice in their question, though, they don't have a root 12. So when we're factorizing, we must change the root 12 before we do that. So root 8 times root b, when we're simplifying, think of a biggest square number that goes into 12. That's root 4 times root 3, which becomes 2 root 3. So now this becomes 84 plus 24 times 2 root 3. Well, that'll just be 48 root 3. Now it's ready for factorizing. As you can see, we can factor out of 12. Open brackets, 12 times 7 is 84. Positive 4 will give me 48. And then just leave the root 3 inside. And we have done what is asked, so that's done. Okay, part B, rationalize and simplify this fraction. Okay, so remember, rationalizing surds is removing the surd in a denominator. Okay, now a lot of my students get these wrong because they forget time and time again how to do this. So they do remember how to rationalize, but it comes from when we have one term at the bottom. So if we multiply the top and bottom by root 2, we will get 2 root 2 over 2, which becomes just root 2. And I think to do the same for fractions where there's more than one term at the bottom. So a lot of students here will just multiply top and bottom by √3 and think that's how you do it, but that is not how you do these questions. When there is more than one term in the bottom, we multiply top and bottom by the inverse sign. Only then will you remove the surd at the bottom. So now this just becomes expanding brackets for top and bottom. I'm just going to do the top first. 4 times 3 is 12. 4 times negative 2√3 is negative 8√3. Minus √3 times 3 is minus 3√3. Negative times negative becomes positive. So that becomes plus 2 times √9, which is 3. So 2 times 3 is 6. Just simplify this. This becomes 18 minus 11 √3. Okay, that's the top done. And now I'm going to do the bottom. 3 plus 2 √3 times 3 minus 2 √3. Okay, so 3 times 3 is 9. 3 times negative 2 √3 is negative 6 √3 plus 6 √3 minus 4 times √9, so that's 4 times 3, which is 12. Okay, now I'm going to bring them together in the fraction. So 18 minus 11 √3 all over minus 3. Well, as you can see here, actually, before I continue, these do cancel, which is good because that's the whole point of rationalizing. So it become minus 3. And that is done. Question 11, we're nearly there. 60% of a sports club's members are women and the remainder are men. This sports club offers the opportunity to play tennis or cricket. Every member plays exactly one of the two sports. Right, so they can only play one, but they have to play one. 2/5 of the male members of the club play cricket. 2/3 of the cricketing members of the club are women. What fraction are the members of women that play tennis? Okay, so this question is make your own value type question. Okay, because they haven't given us a total amount, but we are dealing with fractions or percentages. Now, whether you use 100,000 or 10,000, for example, as long as you've done it right, your fraction will always be the same answer. I'm going to say there's 100 members. So, if we split it into men and women, 60% of the club are women, so that'd be 60. So 40 are men. Next thing I'm going to do, I'm going to call this statement 1 and 2, and I'm going to counteract this statement. So if 2/5 of the male members of the club play cricket, that means 3/5 of male members play tennis. Because this information might be useful. Okay, 2/3 of the cricketing members are women. So 1/3 of cricketing so 1/3 of cricketing members are men. Okay, so let's just look at this for a second. 2/5 of the male members, remember there's 40 male members, okay, play cricket, so we can sort that out. So 2/5 times 40, so this is 16. Right, so there's 60, so what I'm going to do a quick table. So cricket, men and women, and there are 16 men that play cricket. Okay, now 2/3 of the cricketing members are women. Right, now because we have 16 men here, I know that what we could do is we could say, well, if 1/3 of the cricketing members are men, I can then set out an expression for that, 1/3 x. Now, if I make it to an equation, 1/3 of the cricketing members, that's cricketing members, remember, are men, which is 16. And I can solve for x, 3 times 16, which is 48. So this is 48 members here. Then I could just say, well, 48 take away 16 is 52. Sorry, not 52. 48 take away 16, sorry, is 32. So this becomes 32. Okay, so if 32 women play cricket, remember how many women are there? There are 60. So that means if I do 60 take away 32, the remaining must play tennis. 28. And how many women are there in total? There's 6. Sorry, 1 fraction of the members are women that play tennis. Okay, so how many women are there? There's 60. And how many out of those play tennis is 28. And we could cancel that down, but I'm just going to leave that. That is our final answer. I hope this has been helpful, and this is part 1 of the video, and thank you for watching, and I'll see you next time.